Hi, welcome to API Summit 2023. I'm Hisham, and this talk is going to be about WebAssembly and Kong Gateway 3.4. I'm product manager at Kong Inc., and I'm working with the WebAssembly support for the Kong Gateway. So what are we going to be talking about today? Well, we're going to start talking about the WASM tech stack. So what are WebAssembly? What is WASM-X, the underlying technology that we're building to add support for WebAssembly in Kong? So we're going to be talking about WASM filters being added to the Kong Gateway. So this idea of applying chains of filters, what we call the filter chains, to your Kong routes and services in order to add WebAssembly functionality. And then we're going to be seeing WASM in action via a live demo. So let's get started. Well, first, I'm going to start with a quick primer about WebAssembly. Right? So just to make sure that we're all on the same page regarding what is this tech stack, what is this WebAssembly technology all about beyond like the buzzwords, right? So WebAssembly, essentially, it is an industry standard specification for sandbox language runtimes. Don't worry, we're going to break it all down. So the idea first is that being a spec, it means that it is not one single piece of code, one single piece of technology, but rather a specification out of which many different implementations are built off. And by sandbox language runtimes, we mean a runtime, an environment for running different programming languages where those languages run in a safe environment, like in a sandbox, so that they cannot go out and break out of the runtime environment and do like arbitrary things to your system. So everything works in a controlled environment, which is super important when you are embedding languages within a larger application. So WebAssembly is essentially composed out of these different parts, right? The specification. First, it defines a binary format for compiled, essentially in old school lingo, right? Bytecode files, right? If you think about Java classes, this is not unlike Java classes, right? But rather than being a format that was specifically designed to represent a compiled version of Java, this was a new format that was designed to support multiple kinds of languages, right? So it is a language agnostic format for a compiled bytecode files. So once you have those compiled files, so we take like any compiler for your favorite language that supports generating .wasm, like instead of generating, let's say, x86 binary or generating ARM binaries, right? It will generate WASM binaries. You need a machine to run them on, right? So since this is a virtual machine specification, our second piece of the puzzle is going to be a multi-language virtual machine, right? As I said earlier, like this is a specification. This is not like one single vendor providing a virtual machine, right? So you can think of it, when you think about multi-language virtual machines, and when we already made the comparison to Java, we can think of, let's say, .NET. But .NET is a Microsoft standard, so you have this canonical implementation, which is Microsoft's .NET virtual machine, even though there are others. In the case of WebAssembly, since this is like an industry consortium kind of thing, you will have different implementations, which are all in equal standing, right? There is no one like this is the standard, this is all the other ones that everyone tries to copy. Rather, all of the different implementations, and we have WasmTime, we have V8 that comes from Google, we have Wasmer, and we have others. So all of these implement the virtual machine, and they're all equally able to run WASM files compiled with different compilers, right? So you have an end-to-end situation where you have like N compilers coming from different providers, vendors, and open source organizations, which are producing WASM files, and then you have M different virtual machines that are all able to run this code and execute it and provide this sandbox environment. But when you have this virtual machine, it does not live in a vacuum. This virtual machine is intended to be embedded within a larger application. And so that's the third piece of the puzzle, right? You need to have APIs, you need to have programmable interfaces to embed the VM into a host application, right? So of course, the original intention of WebAssembly, as the name implies, was the web. So the original host application for WebAssembly VMs is a web browser. But we can embed it into any kind of application, and as we will see, we will be embedding it into the Conf gateway, right? So in spite of the name, there's nothing specific about the web, either in the WASM file specification or even the virtual machine specification either. So then we come to WASM-X. WASM-X is a Kong project that was being developed by Kong that implements a WASM host using the proxy-wasm API. What does that mean? A WASM host is effectively an application that embeds a virtual machine. But then you say, well, wait, Kong Gateway is the application, but rather Kong Gateway is built out of several components, and it is built on top of an Nginx runtime, right? Nginx is built out of different modules. So these modules contain different pieces of functionality. One such module, for example, is OpenResty, which embeds a Lua virtual machine, and then all of the Lua components that run in Kong Gateway are executing inside of effectively that virtual machine that it's inside that Nginx module. Here we have a similar situation in which WASM-X implements an Nginx module, which on its turn acts itself as a host for different WASM virtual machines. So then we can use this WASM-X module and link it into our Nginx runtime, which is used to run the Kong Gateway. Right. So the end result is that the Kong Gateway has access to launching WASM files, right? But effectively, like behind the scenes, the overall machinery, this is how all of the pieces fit. And one important thing is that when you create a WASM host and you embed a virtual machine, you need to define, okay, so how is the virtual machine going to be talking to the rest of the application? What is it going to have access to, right? So because when you build a sandbox, you need to define what are the pieces that from the host that the virtual machine will have access to in order to not sit in a vacuum, right? Because effectively what we want to do is we want to be executing gateway functionality in this WebAssembly code. So let's say we want to be able to, read and set headers and all those sorts of things. So we need to have APIs in between. And proxy-wasm is a standardized API to allow for that. So that's the one that WASM-X implements in order to give access of gateway features into the WASM code that you will be executing. So once we have all this machinery in place, we get to the point of our application level behavior, right? So if you want to go into the details of the proxy-wasm integration and all of this lower level stuff, I will recommend you check out a presentation that we have. I think it's live on YouTube of one of our user calls back when WASM-X was still at tech preview stage. Whereas we were developing this tech, I gave a presentation that's in the Kong YouTube channel that goes into more depth discussing the proxy-wasm integration and WASM-X and how all of these pieces fit behind the scenes. But since we are now releasing the support as a beta feature in Kong Gateway 3.4, now it's time to really talk about in the application level, right, how we get to actually leveraging the WebAssembly support when using it in the gateway, right? So we're going to be talking about WASM in Kong now. So we need to introduce the concepts of filters and filter chains. So as I said, we are using the proxy-wasm API, and the proxy-wasm API defines this notion of proxy-wasm filters. And this is an API that's the same API that's used for WebAssembly support in Envoy and in other gateways. So this is also intended as an industry standard API. So we are adopting that, and we are supporting it and implementing that as an agnostic API that you can use with Kong Gateway as well. So WASM modules, that implement well-defined event handlers that give access to functionality for manipulating a request lifecycle, right? So this is going to become clearer as we move on and get to the examples later. But essentially, proxy-wasm is an application binary interface that it's implemented by hosts, right? So in our case, WASM-X is our host. So WASM-X implements this binary interface so that the code that you compile with your compiler in your favorite language that becomes a WASM file if it does certain binary calls for proxying applications, proxying operations, those operations will be made available by WASMX so that they will be able to be linked correctly and you will have the desired effect, right? So the other piece of the puzzle here, in order to write the code in your favorite language that gets compiled into WASM, you need an SDK in that language so that you can actually, you know, like whatever dialect your language uses, let's say, like so you can import or you can use or you can require, right, or you can include the proxy-wasm function headers, right, so that you can actually issue those calls and not get compiler errors. So for that, you need SDKs in various languages. There are a few languages that already have proxy-wasm SDKs available. And at Kong, for this beta cycle, we have done extensive testing with the proxy-wasm Rust SDK and the proxy-wasm Go SDK. So these are the ones that we recommend at this point in time. So these are the languages that I should say we could call it giving us tier 1 support, you know, between codes. So that like these are the ones that we have tested and we know that they work end to end. And we're going to be using one of them in my demo at the end of the presentation. Right. So once you take your Rust or Go code and you write your filter logic, you use this SDK in order to do proxying calls, and it gets compiled into the WASM file, what you have effectively is a filter. Right. So these are modules using the SDK that are compiled to WASM. So you'll have something like rate limiting.wasm, like if you implemented a rate limiting filter. So then it's time to load that into Kong. So for that, what you're going to be using is filter chains, right? So filter chains is a new Kong entity defined in Kong Gateway 3.4. Like a Kong entity is something like services, routes, upstreams, you know, certificates, you know, those things that you can manipulate via the admin API, and you have them stored in your database or in your declarative config format file, right? So filter chains is an entity that associates a list of WASM filters to either a route or a service, right? So you can see there in the figure like a declarative config representation of it. A service or a route, and then you will have a list of filters, and each filter can then be enabled or disabled individually, and they will have their own configuration, right? And this configuration is defined by the filter itself, right? Because that's one of the definitions of the proxy-wasm standard, is that the filters define their own configurations and their own configuration formats. So so filter chains in Kong, right? Some interesting things to point out about them, right? So if you add a filter chain to a route and you add a filter chain to a service, and as we know, a service, a route has a service associated to it. So when you get to when the Kong router matches a route, you effectively get a typically a pair, right, being matched, a service and its route being matched. So what happens here is that if you have a filter chain set to the service and you have a filter chain set to the route, both of them will get executed in that hierarchical order, right? First, the filters from the service chain will be executed, and then the filters from the route chain will be executed. So if you are a Kong Gateway user and you're used to the way that Kong plugins work, you will notice that this is a little bit different, because this time around we decided to make things even more flexible, right? So now for filter chains, you define on each chain the order of filters as they're going to run, right? So they don't have like predefined priorities if you're used to that from Lua plugins in Kong. So effectively what you get is that list of filters that you put in your filter chain definition, and the order that you put them in is the order that you're going to be executing. So effectively you will get like the order that you gave for all of the service filters, and then following that, the order of the route filters. Of course, all of that happens per phase, right? And if you're also familiar with the way that plugins execute in Kong, you have something that matches like the Nginx phases and the OpenResty phases, right? So you have access phase and header filter phase, and then body filter phase, and then finally log phase. So what happens effectively is that on each of those phases, you will have first the execution of Lua plugins for that phase, and then the combined filter chain, which is the chain of the service filters and the route filters, right? So effectively, if you have a complex configuration in which you have Lua plugins that run on each of those phases, and you have filters that run on those phases, you get the first phase, Lua plugins run, and then the WASM filter chains run. And then for the second phase, you get Lua plugins for that phase, WASM filter chains for that phase. So effectively, they interleave in that way. So you could have something like, Lua plugins running in an early phase doing the authentication, and then WASM filters doing like header manipulation later on in header filter phase. And then finally afterwards, you can do another Lua plugin doing log phase stuff, or even a WASM filter also doing log phase stuff, and all of that gets executed like in this logical order. So I think it's better to just go to a demo and make things more concrete. So I think that's always more fun than trying to explain things in the abstract. So let's just go ahead and look at that. And let's see. Okay, let's switch to terminal for the demo then. And what I'm going to do is that I'm going to do like an end-to-end execution of what it looks like to get a Kong gateway running and get a filter built, right? So I'm going to be doing this from scratch, and let's make a demo folder here. Just so you can see I'm doing this like from scratch. I'm going to actually clone the repo for an example filter. So at Kong, to get you started, we prepared a couple of template repositories, like one for Go filters and one for Rust filters. So which essentially implements like a hello world filter to get you started, right? So this is going to be the hello world filter. And if we take a quick look at it, so you can see from the scroll bar there that it's not very long, and we even left like a lot of the event handlers already written and commented out, just so you can at a glance just check what's available. And this one has like a small configuration reader, a little bit of boilerplate. It uses a third-party SDK that implements proxy-wasm for Go. And what are we going to do here is that we're going to get a greeting out of the configuration, and we're going to use the proxy-wasm API to add an HTTP response header, right? We're going to add an X greeting header here, which adds our greeting. And then this is also a standard proxy-wasm type, which just says to continue with the request, right? So this is effectively a filter that just implements one standard proxy-wasm event handler, which is HTTP response headers, and that will just add a greeting and continue with the request. So that's like our, gateway world equivalent of hello world. Right. So we're going to go ahead and build this. So we put in like a small makefile that already goes to the typical steps for like generating the statically defined JSON parsing for the configuration, where we're going to get that greeting option, and then we build it. One important thing to note here is that we're going to be using a compiler, a Go compiler that generates WebAssembly, right? So this is not the standard Go compiler. This is TinyGo, which is an implementation of the Go language that was originally designed for embedded systems. And we can think of WebAssembly as a new type of embedded system, right? It's a virtual machine type of embedded system. So they already had like all of the machinery in place to generate Go code for that's efficient for tiny like environments like a virtual machine. So that project added support for WebAssembly. So it just effectively targets, that WASI means WebAssembly system interfaces, right? So effectively, like this is for generating code for an environment that has like no operating system or anything running. So that's like the WASI, like is the pretend operating system that you have in a WebAssembly virtual machine. So TinyGo knows how to target that and generate code that's compatible with that. But as we saw in the example there, like the Go code itself, right? It It just looks like, standard Go code. It's just using a proxy-wasm Go SDK for the proxy-wasm operations. So yeah, so now like we've got a Go filter built right out of that compilation step. So let's prepare a couple of folders here so that we can point to them in our Kong configuration as we start the gateway. And so I'm going to add a folder just to keep things tidy. I'm going to add a folder for our declarative config and a folder for our filters. So I'm going to copy our filter to that filters folder, right? And now let's create a basic Kong configuration, which includes a filter chain, right? So I'm going to edit a file here with the Kong.yaml file. So I'm just going to go and write it from scratch so that we can, so that it doesn't seem like it comes out of nowhere, right? So we start with a service. So let's just go with my wasm service. I'm going to be using mockbin for that. So far, this is standard Go Kong configuration, right? A service and a route. So, yeah, if I keep talking while I type, then I'm going to get things confused more. But name my wasm route, paths. I'm just going to make it standard. So, okay, so this would be a very basic, but actually complete Kong configuration with one service, one route, and just like everything gets proxied over to mockbin, right? So we're going to add one bit to that configuration, which is for this route, we're going to add a filter chain section so that we can add a filter chain, right? So I'm just going to call it my chain. And that's going to have a list of filters. So at this point, like this list is going to be one item only. So we're just going to be adding my Go filter, which is the file that we have just created. And it's going to have a config. So this little syntax here in YAML means like just embed the indented section below as a raw string. So that means we can just put like the JSON here that will be sent directly to the configuration of the filter, right? So hello from Kong using WebAssembly. And that's a full Kong configuration, right? So now we have a filters folder with a filter. We have a config folder with our config. Oh, I ended up reusing the folder name from the Go code, but well, the file is there. So yeah, so now we have everything we need to run the test. So we can launch a Docker image for this, and let's call it Kong wasm demo. And yeah, I'm gonna just type all in just to explain everything that's going on. So I'm gonna mount the volume for that config folder as Kong config, and then I'm gonna mount our filters folder as Kong wasm. And now I'm gonna pass in some environment variables to enable wasm support. And I'm gonna tell Kong where are the filters. We put it in that folder that we have just mounted. And since I'm using declarative config, I'm just going to configure it with database off and Kong declarative config to point to that Kong config file that we have just created, right? And OK, so now we need to assign some ports so we can actually talk to it. 1000. So the port for the proxy and the port for the admin API. And finally, I'm going to use this container here, which is our Kong nightly, because Kong WebAssembly supports in beta, and it's getting better every day. We keep pushing features, fixes, and all that. So let's just use the latest and greatest. So we have a container. So our container, I guess, should be live, and the proxy-wasm filter should be ready to be used. So let's see what happens if let's use HTTP and make sure we show our headers and issue a request here. That should hit mockbin with an echo. And yeah, we got the response from mockbin, which is the echo request, and we've got our added header, right? We've got a hello from Kong using WebAssembly. This is actually Go code running within the Kong core in the gateway, right, as part of the gateway process. That's actually launching a WebAssembly virtual machine, which is calling that Go code compiled into WASM, and then using the proxy-wasm API to call that add header operation and add this header here, right? And that's all that we had to do. Like we just compiled that file into WASM and passed it into the Kong configuration, enable a filter chain, and got things running. So easy and simple. So where are we now? Well, this is out there. Kong Gateway 3.4 is released. So we want you to play with it, give us feedback, give it a spin. It's included in both Kong Gateway Open Source and Kong Gateway Enterprise, right? Of course, at this point in time, since this is a very first release, WASM support is still in beta, which means that the interfaces are still subject to change, right? So, and this also means that there is no LTS guarantee for this particular feature, right? Even though Kong Gateway 3.4 Enterprise, that's the 3.4 series is going to be a long-term support series. The WASM support within that series is in beta stage, so that's not covered by long-term support. But we believe that what's more important here is to get your feedback and get the interfaces right. Like even if based on feedback you decide that okay, no, this doesn't feel like the best way to configure it, or this is missing. So we want to be able to have this flexibility to iterate really fast on the WebAssembly support as we are like in this initial stage, so that we can eventually graduate it into a GA feature, like to term it as generally available, so that it can then be used, in production environments with, with all of the support guarantees that we give to our GA features, but then with, stable interfaces. Like we are trying our best to, of course, to give the best interfaces that we can right now. So that's why we're adopting like industry standards, like proxy-wasm and adopting that filter chain module, which is meant to be very flexible. But still it is, as I said, is getting better every day. So really what I recommend if you want to give this a spin, and I urge you to do, is to run the latest, run it. And the easiest way to do it is to use our nightly builds that are our Kong /Kong nightly containers, because that's always a step ahead, like even ahead of our latest OSS and enterprise releases, right? For in terms of these beta features, right? So just to reiterate, we really want your feedback because we want to make this feature the best that it can be. So do share your WASM filters, your experiences in Kong Nation, our discussion forum, right? So there's the link, and let us know about it. And that's all I had for today. And thank you for watching.